Hey guys, welcome back. So in the last video we learned what is the format of a recursive method, whereby we saw that there are basically two cases in any recursive method, that is a recursive case and a base case. In case of recursive case, we typically call the same method again with a different parameter. However, in base case, we typically return the method and it is normally a termination condition for a given method. So I hope you would have understood what is the format of a recursive method. Now in this video, let's talk about how is recursive method stored in stack memory. Fine. Now before we understand how is recursive method stored in stack memory, let's quickly see how does a normal non-recursive method is stored in a stack. Once we understand that, let's talk about recursive method. So here we have a main method which calls the bar method, and then it prints out some messages. In the bar method, it calls do work method and again it prints some message. Similarly, we go to do work method, there do more is called and again a message is printed, and finally in do more method simply a message is printed and no more method calls is done. Now assuming that the control starts from main method, let's see how all of these method invocations are done by system. So here we have a stack memory, which is basically a memory which is maintained by system for method invocations. Now as we have already learned in stack chapter that anything which comes in the stack is called as push and anything going out from stack is called pop. Also, we know that stack follows LIFO method, that is last in first out. So whatever thing comes in the stack last goes out from the stack first. So if let's say we store number 3 in stack, then if we store number 2 and then number 1. Now if we want to take out an element from stack, we cannot access 3 or 2. We always have to take out 1 first, then 2 and then 3. So this is called LIFO. So in case if you want to know this thing in more detail about stack, please watch the stack chapter. Now let's come back to our method invocation. So let's say the control starts from main method. So the first statement that we see within the main method is call to a bar method. Now as soon as we see a bar method's call, the control goes to bar method. Now after completing the bar method, it needs to come back to main method to execute this statement over here. So what system will do is it will store this main method somewhere so that it remembers that it needs to come back to main method once bar method execution is done. So what it will do is it will push main method in stack memory. So main method goes here. Now this way system remembers that it needs to come back to main method. Now once the control comes to bar method, the first line that we see here is do work method. So once again the control goes to do work method. Now system also again needs to come to bar method to execute this statement. So for that it needs to save the bar method. So again it will push bar method in the stack. So we have bar method in the stack right now. Now once the control is in do work method, the first statement we see is do more method. So once again the control goes to do more method, and do work method needs to be stored somewhere. So this again gets pushed into stack. So we have do work method here. Now interestingly, in do more method we don't have any further method calls. It just has one print statement. So it prints that statement and it's done. So it need not go in this stack. So we don't see do more method in this stack. Now once the do more method execution is done, system needs to know which method it needs to come back to. So who will tell that? That we will get from this stack. So whatever is on top of the stack is the method that will be called. So we have do work method. So system will come to do work method. Now since line 1 is already executed, it will execute the next line, which is printing of this message. So it will print this message. Now once the message is printed, do work's work is also done. So now the system needs to again refer the stack and see which method is there in the stack. So it sees the bar method is there. So this gets popped out. Now the control again goes to the bar method. It prints this message and bar method execution is done. Now system will again come to stack and see what is pending. So main method execution is pending. So now that will be popped out and the message over here will be printed. Once this message is printed, we see that the stack is empty. There is nothing in this stack. That means it tells the system that there are no more executions or method calls which are pending. So with that, all the method execution is complete. So now we have understood how does the method invocations is managed by system in stack memory. Now let's see how is a recursive method stored in a stack memory. So let's see that. So here we have a main method which is calling foo method and the argument is number 3. Now if we go to the foo method, we see that it is taking a number, checking that if it is less than 1, then it simply returns. Else it recursively calls itself with a modified parameter. And what is that parameter? It is n minus 1. So if we pass value 10 over here, it automatically calls itself again with n minus 1, that is 9. And then again it calls itself 9 minus 1, that is 8, and so on. And finally it prints hello world and the value of n. Now let's see how does this method execution is managed in stack memory. So here we have a stack memory. So now once the execution starts from main, the first statement is foo3. So main needs to be pushed in stack because system needs to come back to main once foo3 is executed. So we have main in stack. Now the control goes in foo. The value over here right now is 3. If n is less than 1, no, it is not less than, it is 3. So it goes to else block. It calls foo n minus 1. So what is foo n minus 1? It is 2. 3 minus 1. So foo method automatically gets again called with value 2. Now before calling foo method with value 2, system needs to store this foo method with value 3 because it has some pending work over here. So because of that, it will push foo3 in the stack. Now once foo3 is stored in the stack, system can call foo2. So now the value of n over here is 2. Now again it checks if n is less than 1. No, it is not. It goes to else block foo n minus 1. So what is n minus 1? It is 2 minus 1, that is 1. So again system needs to call foo with value 1. Now before going to that, it needs to execute this. So what it will do is, it will store foo2 in stack and call foo1. Now the value of n over here right now is 1. If n is less than 1, no it is not, else foo n minus 1. So what is n minus 1? It is 1 minus 1, that is, it is 0. So system once again needs to call foo n minus 1, that is foo 0. So it will store foo1 in the stack and it will call foo 0. So once foo 0 is called, it says if n is less than 1. Yes, it is less than 1. Right now the value is 0. So it simply returns. Now once foo 0 is returned, that means foo 0's work is done. So now the system needs to find out that what it should do next. So for that it will come to the stack. Stack says that call foo with value 1. There was some pending work. So system will pop out this one from here and it will come to this statement over here. Now remember that when the value was foo1, then system came till here, that is else foo n minus 1, and it called foo 0. And then it never got a chance to execute this print statement. So now the control will come to this print statement and it will execute this statement. So this statement over here gets executed. So it prints hello world, value of n is 1. Now once this statement is executed, foo1's work is also done. So now system needs to come to stack and see what needs to be executed. So it says foo2 there is some pending work. So it pops out from here and it comes to foo2. So again what was pending in foo2? This print statement. So it will print hello world 2 because the value of n is 2 right now. Now once that is executed, foo2 work is also done. System comes back to stack and sees foo3 some work is pending. So it pops it out. What is pending in foo3? Again the print statement. So it prints hello world and the value of n right now is 3. So it prints hello world 3. Now once that is executed, foo3 is also done. So now system will again come back to stack and see what is pending. So right now what is pending is main. So it pops out main. It comes to main. It comes over here, that is after foo statement. So after foo statement there is nothing to be executed. So it simply terminates. So this is how a recursive method is managed by system internally using a stack memory. So now before wrapping up this video, let's quickly recap what we have learned. So we have a stack memory which is managed by system and we as a programmer do not have much control on it. Stack memory is used by system to manage the recursive calls of a method. So here we had a method 3 which was calling itself recursively multiple times depending on some condition. Now every time it was calling itself or it was calling recursively, all that the system was doing is it was storing the current method with the current values in the stack so that it can know from where exactly it needs to resume the execution of that method once the downstream method's execution is done. So that is all for this video. In the next video, we'll talk about some of the common mathematical problems which can be solved using recursion. Thanks for your time. See you in the next video.